So now we're going to learn about big data science in the cloud, and this is Markus Schmidberger, and Markus is a big data analyst with comSysto. He's working as a big data analyst and HPC and cloud computing expert for comSysto GmbH in Munich, Germany. He did his PhD at the University of Munich in parallel computing for biological data. And his main research focuses on high performance computing and big data analysis in the cloud.
Okay.
Thank you.
Thank you for the introduction and welcome. I will hurry up a little bit and okay. First slide, I think it's a very nice motivation for today's conference. I was preparing a training for next week and I was running the typical Hadoop or big data hello world examples, so running word count on some data, and we had the big election year 2013 in Germany, and I was running on the new agreement between the big parties a word count, and I found big data is coming in there 2 times. So politics are pushing big data in Germany. And so they mentioned they plan to investigate in big data for the development of methods and tools for data analysis. So I think it's a really good motivation that politics in Germany jumps on big data. Okay, so we already have the introduction for myself. I'm now today talking about the experience about 1.5 years working for comSysto. comSysto is a Germany-based, or especially a Munich-based company doing software development. And so we're doing traditional consulting, but on the other side, we're doing the complete product lifecycle. So customers get to comSysto with a first idea of some kind of big data application. We define the business idea. We're doing business analysis on it, and we develop the product, and in the end we go online with the product. So we have a big lean and agile cycle in our company, and more focus on big data technology. As you can see, we have several big customers. A lot of them are from the telecommunication area, but we also have traditional German-based companies in there. And another interesting aspect of comSysto are the tools we are focusing on. So we have a strong focus on open source technologies. So we love to work with MongoDB or with Neo4j. We're doing a lot of jobs with Hadoop. And we are partners from Amazon. So most of my experience I'm talking here are based on Amazon clouds. We already heard a lot about today about big data. It's a big hype topic. We have a different definition. I'm a scientist, so on the one hand, I see, okay, we have technologies and ways to store the data. Everyone stores everything. Disks are cheap. But I'm more interested in the part of analyzing the data, looking in there, what we can find in the data, how we can create business out of it. And here we exactly come in with the point, big data science, and I hope we'll hear more about this today. So for me, is science the part of taking over the data, looking into the data, finding new models, predicting the data. And if you look in your history, what you're doing with data science, it's not statistics. It's much more than statistics. And we heard this in one of the talks before. Somehow you need to be a hacker who can program very fast some Python scripts. On the other side, you need a lot of background about advanced computing, how to run your statistical algorithm on Hadoop. But on the other side, you have to understand the people, the business people, how they want to see the results, how to create the graph for them, for the correlation, for example, you find in the data. If you don't have the feeling, you will run to them for 15 times, recreate the graph, and recreating the graph in big data probably take 3 or 4 hours, so it's not a good way. So you have to understand the business idea to make the best out of your data, and so on and so on. So there are many aspects which has to be covered by a data scientist. And if you talk about data science in the cloud, cloud computing is even a hype topic. Everyone wants to move in the cloud. There are many good aspects why you should go in there. You can scale up, you can look at reduce the in-house costs. But in the end, we're all the time talking about accessing some kind of machines or computing power based in the internet, and more or less we have two big competitors here on the market, but I don't think I have to talk that much about this topic. You should all be aware about that. And now I picked out 4, but more or less 3 topics where we had to put a decision on it in the last several months, and which were business critical decisions. So on the one hand, for one of our customers, we're developing a web-based app, and we're shipping them to the customer of the customers in one country, and then he decided, okay, I want to bring my application to another country. Okay, we're talking about a big data application. We're visualizing a lot of data, so the network traffic isn't very small. But the country we want to go now is on the other side of the ocean, so we have a lot of network latency in there. So we have a lot of delay in the data of representing the app. So it wasn't very funny for the customers in the US looking on the platform sitting in Europe. And the other side, we extended our team, so we had data science sitting now in the US and in Europe, and they all were connecting to our Hadoop cluster sitting in Europe, but then the US people told us, oh, it's so slow, we cannot work on that. And it's the latency we have in the network, and we can find a simple solution in the cloud. Check what's doing Amazon. They are setting up their computer centers all around the world, exactly in these places where it's very difficult to have an excellent network connection to these places. And then using the technology provided by Amazon, so taking snapshots of your volumes, moving them from one available zone to the other, it took us about 2 days moving the complete infrastructure, the several servers and the data from the EU into a region in the US, and the app and the data scientists were very happy. They could use the same application as running in Europe, but in the US, better performance, lower network, and it was only some clicks using the technology provided in the cloud. Another example, it's now strongly coming from our data science team. They're using the open source software R for doing their statistics and evaluation on it. R, very flexible, powerful tool. You have a lot of modules or packages which you can integrate to access different open source or big data technologies like Hadoop or MongoDB. And there's one development environment available called RStudio. It's open source and free too. You can download it to your machine. It's a local development environment. It looks a little similar to Eclipse. And you can program your statistical tools locally. And you probably have a small data set of your big data on your machine. Everything works fine. But what happens if you want to run it on your big database machine, your big Hadoop cluster? Then you probably have to write some scripts, move the scripts over there, use the shell command. It already gets difficult for some statistician. RStudio also provides a server version. So you can install RStudio server version on your data, for example, on the master node of your Hadoop cluster, access it via a web interface, and the web interface looks exactly to your local development environment. So you can go on developing on your master Hadoop node with the same environment, but now having Hadoop and the big data in the background. And for the business intelligence people or statisticians, it keeps the same infrastructure, and it's much easier for them. So we moved our analysis environment to our data, to our big data technology. Point 2, which was very business critical decision in our case, was okay, we want to run some big data technology as MongoDB, for example, on Amazon. But if you check all these cloud providers, it's not like real hardware, just putting more disks in there. In Amazon, it's called EBS volume. Then you have provisioned IOPS on EBS volumes, which guarantee you a special speed of your disks. But it's not real hard disks, so it's some network devices. And if you check all these forums or Stack Overflow, there are many people having problems, for example, setting up an efficient database in Amazon. So you really have to think about what is the right setup for my application on the chosen cloud infrastructure. For example, for MongoDB, there's a very nice white paper written by Amazon and the MongoDB company, giving you a lot of hints, for example, that you probably should set up a RAID with a special number of provisioned IOPS if you want to get the special performance out of it. On the other side, we learned that it's a good idea to check if there are already some experts available which provide you the service for the required technology you're looking for. So here it's called MongoSoup. It's MongoDB as a service, as a German service, which means you can choose MongoDB running on Amazon EU West, which is in Ireland, or hosted here in Munich. So if you have special data protection rules and you want to put your data in MongoDB, you could check for this service. It includes all the required features like 24/7 monitoring and support. You have shared hosting, you have dedicated instances. You have all these Mongo features like replica sets or sharding available. For data protection, there was a blog post I think 2 weeks ago. We enabled encryption for the connection. And yeah, it's a service which is running by the MongoDB experts from comSysto and provides you with the technology hosted by experts. And you don't have to care about the correct setup. On the other side, you probably have chosen the cloud because at any time you can scale up and out and you can get the best performance out of the cloud. So that's very often the main reason people decide to go into the cloud. But who in the room already thought about scaling down? All people throw in money in there, scale up, we have to get faster, we need to have more data, we get up. And if you check your bill, it grows up exponential, and then your cloud solution gets critical because it takes much too much money. So my advice here, take one of the several available monitoring tools to monitor your resources in the cloud, to be aware, on the one hand, what is running in my cloud, and on the other hand, where I'm spending how much money. For example, we now work very hard in our project on these provisioned IOPS. They are spending a lot of money, but if you have a very well-running monitoring tool, you will see that you don't need these provisioned IOPS in so many cases. So we reduced the provisioned IOPS for several of our machines and reduced the cost by factor 27% by just rescaling the provisioned IOPS of our machines. Third point, which was even a little bit business driven, the point, okay, you decided to go to the cloud. One point everyone is talking about the cloud is that you have some kind of vendor locking. So if you decide for Amazon, you have to go with the Amazon technologies. It will be very difficult to move anywhere else. Yes, that's right. But have a detailed look at the decision you did. You have a lot of functionality there available. And for example, take Amazon Hadoop EMR cluster. You have a lot of functionality in there, but it's basically a Hadoop core installation. And if you need more functionality, if you need more speed, if you probably want to have some compression, if you need snapshots, it costs you more or less only a little bit add-on, switching on MapR technologies on the Amazon Hadoop clusters, and you get a lot of additional nice features on top, which will be very helpful in this case. So really have a look on your infrastructure, on your available technologies you've decided to go. And now the funny point to the first speaker in the morning, I've shown these slides to my wife, and she told me, hey, you should talk about data protection too, so it was very funny this morning doing that. Yes, data protection is an important point, and my experience is the point if you start being aware of this topic, you're already very, very far, and you could find a good solution. So we have made a good experience with Bitkom, where you have experts which you can ask for consulting, and on the other hand, there are a lot of technologies and available which you can use to add some kind of technical protection on your data. So on Amazon you have these virtual private clouds which enable you that you have your own IP area and you have some kind of your own cloud area. On MongoSoup we enable the SSL protection, which again, okay, it has some drawbacks, it will reduce the speed, but you can set up data protection rules, and if you're aware of that, it will be very easy for you to think about what are my requirements, what are my data, are they already anonymized, what are my SLAs, where I'm allowed to move the data, and then you're on the right track. Okay, coming to an end, I would like to make some very short advertisement. So if you think about going to the Hadoop Summit, and there's currently running a community voting, so if you have some time, just vote for our talk there. It's about where you can deploy MapReduce algorithms everywhere. And on the other side, if you don't know what to do this night, there's an event at the university here in Munich. It's about big data and even some data protection. So they have 3 speakers, it's for free. It's in the Große Aula LMU, so it's in the central university. So it's probably a nice point to go after the drinks here. And summarizing my talk, yes, we can. I'm promised that big data analysis, big data science in the cloud is possible. We can do it. We definitely need experts and data scientists knowing all the challenges running in there, but you can do it and give it a try and have fun doing your data analysis in the cloud. And as the other one mentioned, don't buy a Hadoop cluster, go to Amazon, make some tests there, and then make your decision about more investigation into big data. Thank you.
Thank you, Markus. That was a very useful and interesting practical guide, I think, to how we actually engineer and how we actually work, moving from the world of our big data world to our real world, if that's what we live in. Do we have any questions that we would like to ask now? Yes, we have one there. Further down towards maybe.
So a very short question. If you are having MapR, why do you still need MongoDB to use in your analysis?
If you have okay, it again depends on the decision. For example, MongoDB, we are using, in MongoDB you have these geospecial features for taking geo-finding in the data. So that's one of the use cases we are using MongoDB, which we can implement in MapR and Hadoop too, but it's much more effort implemented in there. And I think it's depending on the use case. Accessing data in MongoSoup is probably, depending on the application, again, faster than starting a Hadoop job for that. And so it's again very strongly depending on the use case and what you're doing with the data on it. So I think we have MongoDB more for the long-time storage and Hadoop for processing the huge amount of data.
I think we'll draw this morning's program to an end there.